The first thing I'm noticing here is that towards the beginning, we have some weird normals happening on the ground. And so we have some strange behavior happening there. This could be due to normals. It could be due to there actually being holes in the geometry. Not really sure quite yet which it is, but it does appear to happen on the in-between sections. So that's one thing. Another thing to notice is that our smoke simulation is popping. And so this is a classic thing that a lot of folks do, and it's not really fun when you run into this during a test render or a final render, because it basically means you're working off of old caches and your organization sucks. In this case, it was my organization, not yours. So we'll talk about ways to safeguard against yourself, how to set up a scene that is sort of safety-proofed from this sort of situation happening in the first place. And we'll just talk about organization for a bit. We also have debris that's just hovering in midair, and that has to do with us using a animated plate and not the actual simulation with the sides falling off. I thought it was something we could get away with. Turns out we can't. So I think that's an easy fix. We just have to throw in the high-res cache and wait a bit longer. And what else do we have here? And besides that, I'm going to just ramble on about a few things I made notes on. We'll also talk about motion blur, because that's a hot topic when it comes to destruction. This render does not have any right now, and I'll talk about how you can properly set that up, and we'll take it from there. So what you're looking at here is the completed file. I went ahead and did a bunch of other tiny little things, nothing that is major that I haven't taught you before. So this is what the final network looks like. The main thing to gain from a distance here is the fact that we can tell what our sections are by these nice little notes. So if you're ever working in a studio, it's nice to have these labeled so that we have general sections, ideas are captured in these boxes so that it's easier to follow along. And if you really want to, go crazy, you can have little commentary next to anything that gets really complicated. Like, let's say I went really complicated on this wrangle. It would be nice to include notes within the wrangle, or if you have just a general idea that's not obvious, writing that out next to a box is another great idea. So this is not only for other people's sake, this is for your sake, because at some point or another, I'm going to come back to this network, maybe a month or two from now, and I won't really remember every single idea that was going through my head. At a certain point, you just can't keep track of every little idea you had along the way. So be sure that you label your stuff. It's super, super important, and it'll save you and everyone else around you a lot of heartache, that's for sure. Okay, so let's talk about things that can mess up your normals or give you these little black splotches. Well, in our particular network, what I found is that when we go to clean things up, so where is it? Right here, the in-between cleanup, we are going to be deleting pieces. So the first thing that you want to do is check that you didn't actually delete a chunk that lives at the top of the ground plane right there. That's going to be one thing. Another thing to do, which is not as obvious, is be sure that you are always dividing your geometry. You never, ever, ever want to be working with n-gons, because n-gons can cause problems with booleans. It can cause problems with the black specks that you saw before. And even more specifically on this divide, it's always good to check on the don't generate slivers and avoid small angles, because sometimes these polygons can stretch across in weird ways and cause these little black specks to happen. So in this case, the reason why we saw the black specks is because it was Redshift was trying to render out n-gons, and it's not, usually with n-gons it triangulates this at render. I'll show you why it's not doing that later when we talk about motion blur. But because there was an n-gon, it was rendering out black. A simple divide SOP, though, will save you from that issue. So there you go. That's just good to know in the future. When it came to the debris that's floating in midair, that had to do with us using this plate animation section, and that's not so great. So instead, use the proxy geo when you're determining your collisions. It'll take a lot longer to sim, but if we go to our instance debris, you'll notice that I, in fact, brought out the large plate proxy sim, and that guy is just right here. So I just took proxy plates, and I took our points, transformed them, and that became our collision. So there you go. Much better way of doing that. Besides that, let's also talk about motion blur for a minute. It's really important with motion blur to think about what the renderer is trying to do. And so to illustrate this, let's hop over to Photoshop, and I wanted to explain a couple things. So let's play out what should happen. We should have, let's say, a chunk of geometry. Let's say that this is a rock that's flying midair. Let's say it's going this way, right? So this is going to be maybe frame number 40. So that's frame 40, and then it's going to be, let's just go ahead and make a copy of this. This guy over here, and this maybe is, let's say, I don't know, frame 41. Okay, so frame 40 to frame 41. Let's think about what should happen. What should happen here, if we want proper curved motion blur, which again is a really important topic where if you haven't seen that quick tip, there's going to be a link below that'll introduce you to the topic. But what should happen here is that Redshift, Mantra, V-Ray, whatever, is thinking about the geometry for each subframe of this motion. So it's thinking about the geometry rock right here. It's drawing out this rock again. Let's say right here, right? So it's going like that. Let's turn down the opacity a little bit. And it's doing the same exact thing for each one of these substeps until we end up with the final, transition into frame 41. So this is using deformation of the geometry itself to generate motion blur. It's an expensive way of doing it because the render engine has to think about the geometry at every single step. Now, what's maybe a little less obvious about this situation is the way in which the motion blur arc is generated. And so think of it like this. This is geometry which has points, right? So, this is a mesh, it has points on it. And in order for a proper motion blur arc to happen, it needs to line up this point number, which let's say the point number here is 500, with 0.500 on this side as well. It needs to connect the dots in between each subframe to draw this out. Now, the reason why this is important is because one thing that you're likely to run into is a situation where, let's say we have an n-gon. And remember what I just said about n-gons, how they're terrible? Here's why. Usually render engines will triangulate an n-gon at render time, or even in a quad, it'll triangulate that. And the issue here is that if there's an n-gon and it's trying to match up the point number like this, it might draw out the topology differently on these subframes. So it could be a situation where 0.500 isn't here anymore, but maybe it's down here. And that's because it decided at render time to triangulate this. And as a result, the topology changed from one subframe to the next. And that will mess up your motion blur arc, or it just simply won't show up at all. So if you ever see a weird issue where things look a little bit ghostly, like it's almost motion blur, but it's kind of stretching across the screen, or it's doing weird things like that, many times it has to do with the fact that you have an n-gon and your topology is changing for each one of these subframes. So back to what I said again about the divide SOP, this is why that's super important for motion blur. Okay, so that's a good thing to keep in mind. Another thing to keep in mind is that if we want to calculate these subframes, we need to use a time or a sequence blend, I believe it's what it's called. Sequence blend or a time warp. And a time warp basically uses a sequence blend under the hood to do what it does, which is to generate these in-between frames. Now, you don't want to generate the geometry itself because that's really expensive to do that. This is why we cache out points and then we take the piece of geometry to copy over, right? Because if we just do the sequence blend on the points, that's super cheap to do. It's not going to bog things down. So that means that's why we've been doing this, time warp on the points before, the geometry is attached to it. So on everything that you have, you want to be sure that you're caching this out as points and that you're sticking geometry onto the points because we need those in-between frames and it's really cheap to calculate the in-between frames when it's just a point. So that's another useful thing to keep in mind when it comes to motion blur. Also, what's not so intuitive about this is that if you're using a time shift and a time warp, which, features that sequence blend right here, you need to be sure that the time warp happens after the time shift. Because the time shift, if you put it after the time warp, will basically get rid of those in-between frames, especially if you have integer frames checked on. So just watch out for that because it could also mess things up if you switch these two around. If you're using Redshift and you want to prevent it from ever trying to triangulate an n-gon, you can also uncheck this triangulate n-gons option right here. That's under Redshift OBJ, render, and there it is. And if you're wondering what the deal is with motion blur on the volumes, I decided not to use the velocity volumes because it takes a long time to read this into Redshift at render time. And honestly, I just didn't like the result because it just looked too smudgy. This is just a personal preference, but do realize that if you use velocity, you'll need to cache this out. You'll probably want to optimize this by, downsampling and then resampling once it's, been cached out. It really adds a lot to your cache files. And, again, in my case, I just didn't like the look of it, so I left this out for that reason. Go ahead and take a break if you need to, and in the next video, we'll talk about some other stuff.